Hello everyone, my name is Roman. This is my talk Automating Audio Tests, and I'm going to tell you how we simplify manual testing and run UI tests at Yousician. Let me introduce myself. I am a quality assurance automation engineer at Yousician, and I've been testing mobile apps for 5 years. What is Yousician? Yousician is an app that teaches you how to play 5 musical instruments anytime, anywhere. You can learn guitar, bass, ukulele, piano, and how to sing. Yousician is available on all popular platforms, both desktop and mobile ones. We have 20 million monthly active users, and they love our app because we deliver a gamified user experience to keep the learning process engaging. Our app processes incoming audio to evaluate how you play, and it heavily relies on custom digital signal processing and neural networks. Here is the plan for my talk. First, I will tell you about audio testing in general. Then, I'm going to briefly introduce our approach in automating UI tests of apps made with Unity. Right after that, I will demonstrate how we test audio input. Then, we will dive into technical details to see how we set up the audio testing. Finally, we will go to a conclusion. Let's begin. What is so special about audio testing? The important thing to remember when we test an audio input or output is that it comes with special challenges. Usually, additional hardware to playback and record audio is required. For example, you can use both acoustic and electric guitars with Yousician. Also, you can listen to the backing track with wired and wireless headphones, or without any headphones at all. Next, you have to keep in mind different test preconditions. There are different background noises we expect the app to ignore. Also, system audio settings make a huge impact. Finally, there are issues that can only be found during end-to-end testing. These specific issues include microphone permissions issues, hardware configurations incompatibility, and audio drivers issues. Our app features bring another layer of challenges. First, playing skills are required to test things properly. Next, the app provides real-time feedback and expects notes and chords to be played at the right time. Finally, multiple supported platforms, 5 instruments to choose, and hundreds of songs available in the catalog make regression testing critically cost inefficient. In this talk, I will tell you how we simplify manual audio testing and set up automated UI tests. Now we know the audio testing challenges, but there is also something special about testing apps made with Unity. When we test native apps, we use testing frameworks to automate UI tests. It works like this. We send actions to the test target and receive information about UI elements on the screen. This scheme shows the data flow between a test target and a test runner. The UI test is a sequence of steps. Tap something, get the UI changes. Swipe something, and get the UI changes again, and so on. Our app is made with Unity, a popular game framework. This way, we can significantly speed up a development process because we don't have to create a separate app version for each of the supported platforms. The problem is that the apps made with Unity do not provide UI elements information. To automate UI testing, we added a remote procedure call service based on Google's gRPC. It works over the network, and the app sends the UI elements tree over it. Thanks to it, we know what elements are displayed and where they are on the screen. This way, we can utilize a commonly used testing framework, Appium, but instead of asking it to interact with an element, we send actions for coordinates. The service is only available for internal app builds. Using this gray box testing technique, we can also add additional test-enabling features. We can save the logs from Unity on test failures to debug the issues. Getting the evaluation data when the song is completed allows us to create very detailed test assertions. We received information about every single note we played and when we verify when. Finally, we can ask the app to instantly open the universal links to speed up test execution. Now we know how to set up UI tests for apps made with Unity by adding a special service, and also how to enhance our sessions by getting the evaluation data. Let's see how to test the audio input. In this example, we are going to test Apple's Siri and its Spotlight feature. If you are unfamiliar with Apple's operating systems, hear how it works. I can swipe down to launch Spotlight. Then I type my search request and receive the information sent by Siri. Let's automate this scenario, but this time we will use dictation instead of typing. This is a custom test tool we made to test audio apps. It is made with Juice, one of the most popular audio application frameworks. Our tool is similar to the most audio players. Here we can choose audio to play. We can also play back audio with it and control it. We can also configure the audio settings in any way we want. The most important feature, however, is an integrated open sound control server. It is listening for commands that allows us to control test tool during automated test runs. You can see the information panel, and in that, test tool received multiple commands. Thanks to the open source Open Sound Control Protocol that is already implemented in Juice, we can automate the test tool with any testing framework. This is how it works in a test code. This is a test case written with Swift that automates the Spotlight scenario I mentioned before. First, we initialize the apps we are going to work with. Springboard is a home screen of our device. On the next line, we initialize the Spotlight. Then, we set up the test tool library and prepare to send commands over the internet. As a setup, we route the sound to an external speaker and set the active channels. During the test, we firstly swipe down to activate the Spotlight, then we tap the Dictate button. Right after that, we ask the test tool to open the audio and to start playing it. The last thing to do is the assertion. We grab the first result cell by its identifier and verify it contains last year's winner name. Let's run the test. Everything goes exactly as we want to. Swipe down, dictate.
Eurovision winner.
And verify results. The test passes successfully thanks to the test tool. Now we learned how to use test tool to test audio input scenario. Next, I will tell you about setting up the audio testing. Let's start with something we already know, how to set up testing on mobile devices. We need a USB cable to deliver power and actions from the test runner. Next, we need a speaker to play the audio with the test tool. To run tests on desktops, we move the test target. We move the test tool from the runner to the target. As you remember, we can control the test tool over the OSC protocol. It is basically an internet protocol. We need to set up a replacement for the audio interface on the test target. Luckily, there are virtual devices that loop the input audio and output audio. You can see that only a network connection is needed between test runner and the desktop target, which means we can easily scale desktop targets. To connect mobile devices, we need a USB hub. An audio interface with multiple inputs and outputs is required to connect multiple speakers that play different audio at the same time. That's what we need for mobile devices. And finally, we use wooden boxes to isolate the speakers. Currently, we have 8 test targets. There are 2 different devices running 2 different operating system versions for every platform. 2 iPhones, 2 MacBooks, 2 Windows laptops, and 2 smartphones running Android. To simplify maintenance, especially during the work from home period, there is a remote connection available for desktop targets and the test runner. Devices can be rebooted automatically and on demand. To ensure test stability, we prepared a test target setup checklist for every platform. The automation room is not the only place to run the tests. We can also run them on personal devices. This helps to reproduce issues and investigate them in detail. Let's see an example how we run tests for audio input of our app made with Unity. First, we use a universal link to instantly open the song. Then we give the microphone permission and use the test tool to play guitar for us. At the end of the test, we can verify the number of green notes and the average playback offset. I'm glad we have this setup, because I cannot play guitar that fast yet. Let's go to conclusion. We managed to run UI tests for apps made with Unity. A custom service also improves our automation by sending the evaluation data and by opening universal links. We additionally simplify manual testing and improve its cost efficiency by creating a custom test tool. Thanks to OSC, it can also be used to run automated UI tests. We set up the automation room while solving different problems with sound isolation, test scalability, and maintenance. We also prepared this talk because we sincerely want to share this knowledge about things we learned. Thank you very much. Now I will happily answer your questions. By the way, you don't have to read the text at the bottom, it's just information about trademarks.